Yes, good morning, students. We have been discussing about addressing modes, right? In the last class, we have seen the different types of addressing modes and the two addressing mode that does not need address. Okay, there is no address field required in these addressing modes. The first one is implied mode, correct? Here, the operands are specified implicitly in the definition of the instruction. We don't give the address here. Okay, automatically the operand is the register taken as accumulator, okay, for storing the operands. And immediate mode, the operand is given directly in the instruction. Okay, we don't have address field here. And then we discussed about register mode. In register mode, the operands are stored in registers in the CPU. Okay, so here the address, in the address field, we have the register address. Okay, there is no memory reference needed here. We don't store the operands in memory. When the operands are stored in register, the address field will have the register address. So this mode is called register mode. And direct or absolute addressing mode. Direct addressing mode is the address field will have the effective address. Okay, so we call it as direct addressing mode. The effective, to fetch an operand, we need the effective address of the operand. If it is given, we use that. If it is not given, we need to find the effective address. The first step is we need to locate the effective address and then locate the operand. But here in direct addressing mode, we will have the effective address in the instruction, okay, in the address field of the instruction. So this is direct addressing mode. And the other type of addressing mode is indirect addressing mode. Okay, in indirect addressing mode, the operand, the address field will not have the effective address of the operand. Okay, the address field will have the location of the effective address, where the effective address is stored. Okay, it may be in memory or in register. So the address field of the indirect addressing mode instruction, okay, will have the address of the effective address in the instruction. Okay, so we need to locate the effective address first. That is the first step. And the second step is to locate the operand. We have two types of indirect addressing mode. Okay, one is memory indirect addressing and the other one is register indirect addressing. When the effective address is stored in memory, okay, we call it as memory indirect addressing mode. When the effective address is stored in memory, in the instruction, what we have in the address field is the memory address. Okay, so it is memory indirect addressing mode. And when the effective address is stored in the register, in the instruction, okay, in the address field of the instruction, we will have the register address. So that is called register indirect mode. Finally, the operand is stored in memory only. Finally, the operand will be in memory. Okay, but the effective address, depending on the location where the effective address is stored, okay, we call it as memory indirect addressing mode or register indirect addressing mode. When the effective address is stored in memory, it is memory indirect addressing mode. When the effective address is stored in register, it is register indirect addressing mode. We have seen the example also. Okay, this is register indirect addressing mode. Okay, because the effective address is stored in register R1, effective address is B. And this is memory indirect addressing mode. Okay, here the location is A. Okay, the address of the location of the effective address is A. Okay, that A is the location of memory. So this is memory indirect addressing. And we also discussed about this auto increment and auto decrement mode. It is same as the register indirect addressing mode. Okay, the effective address will be there in register, one of the register. And the difference is when the operand is stored in a table in memory, we need to locate the operands one after the other in a table. Okay, so the address need to be incremented or decremented. Okay, so automatically once the operand is located, it is the address of the register, okay, will get incremented or decremented. Okay, so we call it as, this is auto increment or auto decrement mode. And the next, we'll learn about the other addressing modes here in this class. It is relative address mode. The first one is relative address mode. Okay, in this address mode, the address part of the instruction, okay, in the instruction we will have the address, and that address is added to the content of the program counter to locate the operand. Okay, how we find the effective address of the operand? The effective address of the operand is obtained by adding the content of the program counter with the address of the instruction. Okay, the address that is given in the instruction is added to the program counter. So here, effective address is content of the program counter plus the address of the instruction. So when we need such type of addressing, the program counter is the register that stores the address of the next instruction, correct? Okay, so we have in memory, we have the instruction stored. So PC will be pointing to some instruction that is to be fetched for execution next. And suppose if the instruction is load A, okay, here A is not the effective address. These are all the different indirect addressing. Okay, there is no direct address here. A is not the effective address of the operand. Now the effective address need to be calculated. How we calculate this? Okay, if suppose this is A in memory, this is location A. Okay, and the address of this, let's say the address is 200, and let's say PC is 50. Okay, 50th location in memory. The instruction that is at the 50th location is the next instruction. So program counter is holding the address 50 here. And our instruction is load A at location A in memory, that is at address to 200. So now this address is added, okay, added to the program counter. So the address of A is 200, 200 plus 50, okay, somewhere we have 250 here, and at this place we will have our data. Let's say our data is 20. This is what is the operand. Okay, so to fetch the operand, we calculate the effective address by adding the address part of the instruction, that is A. Okay, the address part of the instruction is A, the memory location is 200. Okay, we add the address part of the instruction to the content of program counter. In our case, content of the program counter is 50. Okay, so at this location, when you add, you get the effective address. So 250 is the effective address. We find the operand at that place. So this type of addressing is used when the operand, the position of the operand is related to the position of the instruction. Okay, instruction is the program is being executed. So when the operand is stored, okay, the location of the operand is somehow related to the address of the instruction. Okay, in this case, we use this type of addressing, relative addressing. Okay, this is relative address. And there are two more displacement type address. One is indexed addressing mode and the other one is base register addressing mode. These both are almost similar, only the register used is different. Okay, indexed addressing mode. In indexed addressing mode, the effective address of the operand is obtained by adding the content of the index register to the address part of the instruction. Okay, the address part of the instruction is, let's say, A, and the effective address is obtained by adding the content of this address to the index register. Okay, so index register, it is denoted as XR. Okay, XR is the index register that resides in the CPU. Okay, when the array of operands, okay, array of data is indexed. Okay, that is when we use index register, right? When the list of data is indexed. So the index register will hold the index. And in memory, we have this type of indexing is used when we have array of data. So let's say we have an array A, okay, it is starting at location some 200, and we have a list of data available in the memory. And this is our operand. Okay, the operand at this location is the here. This address is the effective address. Okay, so let's say this is the 0, 1, 2, 3, 4, 5, fifth element. So XR will be holding the index 5. Okay, array index from 0 to the number of 0 to n. So it will be holding the index of the array. Okay, so let's say that the value of index register is 5 and A is our address, okay, given in the instruction. So to find the effective address, how we find the effective address here? The content of the index register plus the address part of the instruction. Okay, the address part of the instruction is A, that is the address is 200. It is added to the content of the index register. It is 5. So we get the address 205. Okay, so this is our effective address. Okay, effective address is obtained by adding the address part of the instruction to the index register so that we can locate the elements of the array. Okay, so in this case, indexed addressing mode is used. And base register addressing mode. Okay, in CPU we have a register, okay, called base address register. Yeah, this will hold the address, okay, address of the instructions. So when the address part of the instruction is added to the content of the base register, we get the effective address. Okay, here in this base register addressing mode, effective address is obtained by adding the content of the base register to the address part of the instruction. Okay, so this is generally used when the program is this hold the address of the instruction. Okay, so when the program is relocated in memory, when the program is relocated to find the instructions, to execute the instructions, okay, we need to locate the address. So the address given in the instruction is added to the content of the base register, okay, base address register, and we get the new address, okay, location of the instruction. So this way, effective address is calculated in all these cases. We use some computation here, right, to calculate the effective address. In relative address mode, content of the program counter is added to the address part of the instruction. And in indexed addressing mode, content of the index register is added to the address part of the instruction to get the effective address, that is the address of the operand. And base register addressing mode, the content of the base register is added to the address part of the instruction to get the effective address. So here, yeah, when we compare all these different addressing modes, the first one, immediate, implied, anyway, there is no address field at all, correct? And when the addressing mode is immediate, the operand, we will have the operand in the instruction. What we have in the address field is the operand, direct operand, okay? There is no address in the immediate mode. Okay, so that operand is directly used for performing operations. So we have what is the, okay, let's say our instruction is load A. Okay, let's say that our address is A in case of memory address, and in case of register address, it is R. Okay, we use the letter R for denoting the register address and A for memory address, okay, in this table. So immediate address, what is A given in the instruction is the operand. Okay, it is not the address. And the second case, in case of direct address, okay, if the address is direct, what is the effective address? Here we are seeing how we find the effective address from the given address A or R. Okay, the address given in the instruction may be A in case of memory address, R in case of register address. But it may not be the effective address in all the cases. Okay, we will have direct address or indirect address. So in indirect addressing, we need to find the effective address of the operand. So this table shows how in different addressing mode, the effective address is calculated. Okay, in immediate mode, operand A is the address in the address field. Okay, the value in the address field is the operand itself. There is no address. And in direct addressing mode, the address in the addressing field is the effective address. We don't need to calculate the effective address, correct? Okay, the A, address A in the address field of the instruction is the effective address. That is direct addressing mode. And in indirect addressing mode, the address, okay, address in the address field is A. We need to find the value stored at that particular location. That is the effective address. Okay, so we enclosed here this A within bracket, okay, to denote that it is the value of A. It is not A. Okay, it is the value that is stored at A. Okay, that is the effective address. You remember? If the instruction is load, we have written it. If the instruction is load A in memory at this location A, okay, we will not have it is, let's say here it is 250. This is location 200. Okay, A is at location 200 and the value in it is 250. So this 250 is not the operand, this is the effective address. So in memory, you need to locate 250 and in this place, we will find the operand. Our operand is, the data is 20. Okay, so now this 20 is as per this instruction. Okay, the instruction is load A. So this loads the value of 20 to the accumulator. Okay, AC accumulator will be loaded with the value 20, that is at location 250. So here the effective address is 250. It is found, the effective address is found at, okay, the given location in the instruction. Okay, so it is the value of A. Okay, in indirect addressing mode, effective address is the value present at location A. And the next addressing mode is register addressing mode. What is the effective address in register addressing mode? It is the address of the register R that is given in the instruction. Correct? Okay, what if it is comma R2, move the content of R2 to R1. So in R2 we will have the operand. So this is the effective address here. Okay, the register R is the effective address, what is given, that is register addressing mode. And indirect addressing mode, we have another indirect addressing mode, register indirect, that is the effective. We have seen in this example that effective address is stored in the memory. Okay, so here this is memory indirect address, what we discussed is. And in case of register indirect addressing mode, the effective address will be there in register. Okay, so if this is our instruction, move R1 comma R2, here R2 is this is register. If it is register indirect mode, in register R2, we will not have the value of 20. Okay, we will have the address, effective address of the operand in memory. What is the effective address of the operand? Our operand is 20, data is 20. So the effective address is 250. That we will have in this register R2. So the value of register, okay, that is why here we have enclosed it in bracket. Register indirect mode. Okay, the effective address is the content of register R. The content of register R. Okay, in this case it is 250. At this location we find the operand. So that is effective address. And displacement, we have learned 3 displacement modes. One is relative addressing mode, index register addressing mode, and the other one is base register mode, right? Indexed addressing mode and base register addressing mode. So here this R may be, okay, when it is yes, and displacement. There are 3 displacement modes. One is relative addressing mode, indexed addressing mode, and base register addressing mode. Okay, so in relative addressing mode, this is the address given in the instruction. Okay, A is the address given in the instruction and the content of one of the register. Okay, so it may be the register may be R may be PC in case of relative addressing mode, and it may be XR in case of indexed addressing mode, means the index register, and it may be base address register in case of base register indexing mode. Okay, these are the 3 displacement modes. The content of one of these registers will be added to the address given in the instruction to find the effective address. Okay, so effective address is A plus the content of the register. Okay, PC XRR BAR, base address register. Okay, hope this is clear. If you have any doubts, you can ask me in this addressing mode. Okay, this is one of the important question in this chapter. Okay, most frequently asked. You have to write what is the addressing mode, and I will give you one example here. Please tell indexed addressing mode once again. Indexed addressing mode. Yeah, indexed addressing mode is, okay, here the effective address is obtained by adding the content of the index register to the address part of the instruction. Okay, what we have in here, let's say one example, let's take this instruction, load A. Okay, what is A here? Here is some address. Okay, but this is not the effective address. We will not have this is a kind of indirect addressing. Okay, indirect addressing. In indirect addressing, we will not have the effective address in the instruction. We need to find the effective address. So here, this is not the effective address. So to calculate the effective address, okay, what we have to do is we need to add the content of this, okay, address field in the instruction. We need to add this A to the content of the index register. Okay, the index register that is maintained in the CPU, it will have the value. That value need to be added to this address A to find the effective address. Okay, this is generally used when when we have an array of elements stored in the memory and we want to access those elements. Okay, so when we need to locate a particular element, we will have the initial address in the instruction. Okay, we don't know the index value. Okay, so to access the elements, but index register will have the index value. Okay, in the instruction, we will have only the initial address where the array is starting. To locate some other data, what we do, we add the content of this address, okay, address given in the instruction to the content of the index register. So we can locate the particular data in the array in memory. Okay, so here to access the fifth element in array, the index register is holding the value 5. Okay, and the address given here in the instruction is A. Okay, if you see in memory, it is 200. The address is 200. So this A is added to the index register. So 200 plus 5, we get the address 205. At this location, we get the operand. Okay, so when the effective address is calculated in index addressing mode, effective address is calculated in this way, adding the part of the instruction with the content of the index register. It's clear? Okay. So let's take this example to understand this, all these addressing modes. Okay, the part of memory is shown here at location 200 in memory. Okay, here it is starting at location 200, and at location 200 and 201 we have an instruction. Okay, it is a 2-word instruction. Okay, otherwise we see instruction in 1 word, right? But here the instruction is occupying 2 words, 200, memory word 200, and at location 201. Okay, so what is the instruction? It is generalized form of instruction. This load to accumulator, and here is some mode given, address equal to 500. So what is the address given here is 500 in the instruction. Okay, this need to be, the meaning of this instruction is this need to be loaded in the accumulator. 500 is the address. Now we'll see how, when different addressing mode is used. Okay, the addressing modes we have learned here. Okay, what will be the value stored in the accumulator as a result? Okay, once the instruction is executed, and when different addressing modes, okay, are used. Okay, for different addressing modes, what will be the final value stored in the accumulator? So here in memory, at 200 we have this instruction 200 and 201, and at location 202 we have the next instruction, and we have the operands. Okay, data stored from location 399. At location 399 we have 450. Okay, this way the data are stored in different locations. And in CPU we have the registers. The content of registers are given here at the right side. PCS, the content of PC is 200. And here is a general purpose register shown. Okay, when the instruction has a register, address field has the register. Okay, the value stored in the register is 400. R1 is 400. And an index register is shown here, XR. The value stored is 100. And we have the accumulator finally, where the result is stored. Okay, we are going to load as per the instruction. We are going to load the content of, we have to calculate the effective address first. The address given in the instruction is 500. Okay, if it is immediate mode, this is the data. This is not the address. This is considered as data. And if it is direct mode, this has to be considered as effective address. And indirect addressing mode, based on the different modes, we need to calculate the effective address. And finally, that value need to be stored in the accumulator. Okay, so if it is, now look at the table, if it is immediate, the first case, immediate operand. If the addressing mode used is immediate, here, when the addressing mode is immediate addressing mode, the effective address, okay, there is no address. In immediate mode, there is no address. The directly what is given in the address field is the operand. There is no effective address here. No need to find the effective address. So what is given in the address field of the instruction? It is 500. Okay. So we write this value because it is an operand that will directly get stored in the accumulator. Okay, in accumulator we will have 500. Okay, this is our register accumulator. The data we will have after execution of this instruction, when the mode is immediate, it is the same value what is given in the address field of the instruction. Okay, so the content of AC will be 500. And the second case, direct address. Okay, so in what is direct address, the address field is the effective address of the operand, right? In case of direct address, the address field is the effective address. Okay, with the value given in the address field is the effective address. So 500 we consider as a 500 in the address field, we consider as an effective address. So we need to now locate the operand at location 500. So in memory, what is there at location 500? It is the operand is 800. So this is the operand, right? This is the data that is loaded into accumulator. So accumulator will have the value 800 once this instruction is executed, and the addressing mode is direct. Okay, in direct addressing, the address given in the address field is the effective address. So we directly go to that particular address and locate the, we find the operand and load it in the accumulator. And the third case, indirect addressing. Okay, it is indirect address means it's memory indirect. Okay, for register indirect, we write it in register indirect addressing. So this is memory indirect addressing. Okay, and look at the instruction. In the instruction we have 500, and this is not the effective address. So how we calculate the effective address? We first locate this 500 in memory. The value at this particular location is the effective address. So in this case, 800 is not the operand. 800 is the effective address of the operand. So now we have to go to location 800, and the value at that location is the operand. Okay, so here what is loaded into accumulator, the operand is 300 because it is indirect address. Okay, we consider the address given as the address of the effective address. Okay, location of the effective address. So 500 is the location of the effective address. Effective address is 800. And at that location, we find the operand, that is 300. And the next one given here is relative address. Okay, relative address, how we find the address, how we find the effective address in relative addressing mode. We add the content of the address field, okay, given in the address given in the instruction to the content of PC. What is PC here? Program counter is 200. And what is given in the instruction? The address given in the instruction is 500. Okay, it is 500 plus 200. It is not 500, it is not 200 PC, because when this instruction is executed, you need to note this. When this particular instruction is executed, PC will be pointing to this location, the next location. Okay, because we are during the execution of this instruction, particular instruction, PC will be pointing to the next instruction. So this case, PC will be to not 2. That is the next instruction. Okay, so this value, okay, content of PC to not 2 is added to the address of the instruction 500. So what is the effective address? It is 702. Okay, we move to 702 in memory, and this is the effective address 702. Okay, and the operand at that place is 325. Okay, that is our operand, that is moved to the accumulator. So accumulator will have the operand 325 after the execution of this instruction, and when the mode is relative addressing mode. And the next addressing, indexed address. Okay, so in this indexed addressing, how we find the effective address? We add the address given in the instruction to the content of the index register. Okay, what is the address given in the instruction? It is 500. Okay, so 500 plus index register is XR is 100. Okay, here. So when you add this, you get 600. So this is the effective address of the operand. Okay, address in the instruction is 500, and the address in the, the value in the index register is 100. When you add, it is 600. This is now the effective address of the operand. Okay, so here in the table, effective address is 600. How it is found? It is found by adding XR plus 500. And now we to locate the operand, we go to location 600, the effective address, and what is found there is 900, right? That is moved to accumulator. Accumulator will have 900 after execution of this instruction. Then the next addressing given here is register addressing. Okay, we know what is register addressing. In register addressing, we will have the address of the register in the instruction. Okay, so the register is R1. Okay, so the instruction would be, okay, in the instruction, we will have R1. Okay, so the content of, what is the content of R1? It is a direct addressing. Register addressing, a direct kind of addressing. So in R1, what we have is 400. So that is moved to accumulator. We don't need to calculate the effective address here. And register indirect. Okay. In this case, if the instruction will have R1, in the address field of the instruction, we have R1. Okay. And now R1 is located, and the value stored in the content of R1 is, right? The content of R1 is the effective address because it is indirect. Register indirect addressing mode. Okay, so the content of R1 would be the effective address. What is the content of R1? It is 400. So this is not the operand. This is the effective address of the operand. So in memory, we locate 400. Okay, so at location 400, we have the data 700. Okay, so we move this 700 to accumulator. Okay, after the execution of instruction, And when the addressing mode is register indirect, accumulator will have 700. Okay, understood? This is register indirect. So we will not have the effective address, okay, in the instruction. The address given in the address field is the address of the effective address. Okay, so R1, we locate register R1 first. What is stored in that is the effective address of the operand. So we need to locate this in memory. Okay, at this location, what is given is the operand, that is 700. And the next addressing mode is auto increment. Okay, we have two more addressing modes, auto increment and auto decrement. We have learned that auto increment and auto decrement addressing modes are a special case of register indirect addressing mode. Okay, it is a special case of register indirect addressing mode. So here it is same as register indirect addressing mode. What is in R1? First R1 is the address given in the instruction. So R1 is located. What is there in the content of R1 is the effective address of the operand. Okay, and here it is, as it is auto increment mode, the address will get incremented after execution. Okay, you need to note this here. In auto increment mode, the increment happens. Okay, here it is given clearly, AC is R1 plus. Okay, so first R1 is moved to AC. Okay, content of R1. What is the content of R1? 400, and locate the 400. The value is 700. So 700 is moved to AC, and then the address is incremented in auto increment mode. So after the execution, the address will be 401 in auto increment mode. Okay, address will get incremented after execution. So first 700 is moved to accumulator, and then it is incremented. So we will not have the content in at this particular location, 401 in accumulator. We will have the content that is in 400. Okay, because the increment is done after execution. And auto decrement mode. In this, the decrement of the address, okay, decrement is done before execution. Okay, you note this here. AC is minus and then the content of R. So first it is decremented. Okay, what is the effective address? What is the content of R1, right? Is the effective address, that is 400. And as it is auto decrement mode, it is decremented first. When it is decremented, the address would become, effective address would become 399. And the content at that location is 450. Okay, so in accumulator, we will have 450 in auto decrement mode. Okay, this is because in auto decrement mode, the decrement is done first. Okay, content of the register is decremented first, address is decremented, and then the operand is located at that location. Okay, but auto increment, execution first and then increment. So when it is executed, the instruction says to load the content into accumulator. So 700 is loaded into accumulator first, and then it is incremented. So we will have the same value, 700. Okay, that's about addressing mode. Okay, this example is given, okay, to understand the calculation of effective address in case of indirect addressing. Okay, and in direct address, how the operand is fetched from the memory. Any doubts here? And let me check the attendance. 508 present. Okay.